Welcome to this video. Welcome back if you came from part 1. I'm continuing this 2003, I believe, AP Calc BC multiple choice part of the exam, no calculated portion. And I left off on number 15. So let's continue. The length of a curve from x is 1 to x is 4 is given by this guy. If the curve contains the point 1, 6, which of the following could be an equation for this curve? So length of the curve, arc length, is given by this. So remember what the formula for the arc length is integral from a to b, square root of 1 plus dy dx, quantity squared, or quantity as in just the dy dx, squared dx. Okay, so if we just kind of match these two, we can pick that our dy dx squared is 9x to the 4th. Okay? Or dy dx, if we square root, is 3x squared. And our x is positive because it's from 1 to 4, so we can probably just take just the positive, okay? Because usually when we square root, it's plus or minus. But again, since x is from 1 to 4, we can just take the positive, okay? So now we find y. We can just integrate both sides. We'll find the antiderivative. Y is equal to x cubed plus c. Okay, and we're given our y contains the point 1, 6. So 6 is equal to 1 cubed plus c. So c is equal to 5. Okay, so our y is equal to x cubed plus 5. And that matches choice B over here. Okay, this is testing a few concepts in one. Arc length and solving this simple differential equation here with the initial condition. If the line tangent to the graph of f at the point 1, 7 passes through the point -2, -2, then f prime of 1 is what? Okay, line tangent to the graph of the function at the point this guy passes through the point this guy. So this point is on the tangent line. Okay, so, because remember, if I just sketch it, whoops, pretend the lines are touching, okay, they touch at the same point. So this point is both on the function f and on the tangent line. So this point and this point are on the tangent line. Therefore, we can find the slope of the tangent line, which is the derivative. Okay, so change in y would be 7 minus -2 over change in x, which would be 1 minus -2, which is 9, because 7 plus 2 is 9, over 1 plus 2 is 3, which is 3. 16 is C. Curve C is defined by the parametric equations x is t squared minus 4t plus 1, and y is t cubed, which is the following is the equation of the line tangent to the graph of C at the point -3, 8. Okay, so slope of the tangent line, or equation of the tangent line with the slope of the tangent line, which is the derivative. Okay, so we need dy dx, which again is dy dt. We did this a little earlier, dx dt. Okay, so dy dt is 3t squared. Dx dt is 2t minus 4. Okay, now we need to find dy dx at this point. What value of t gives us this point? Okay, so just by picking the easier one, y is t cubed. So what value of t is t cubed equal to 8? That's when t is 2. And we can double check that when t is 2, we get x is -3. We get 2 squared, which is 4, minus 4, which is minus 4 times 2, which is -8. So 4 minus 8, which is -4, plus 1, which is -3. That's correct. So we want to evaluate this at t is equal to 2, which will be 3 times 4 over 2 times 2 minus 4, which is 12 over, did I do this right? because it'll be divided by 0. Okay, so this is, the slope would be infinite, which means that, there are two choices. When the slope is infinite, that means it's a vertical line, because when it's a flat line, the slope is 0. So when the slope is infinite, it's a vertical line. These two are vertical lines, so we can already cross out C, D, and E. Okay, so since the point was at -3, 8, the slope of the tangent, that equation of tangent line should be x is -3 then, as a result. Okay, so the answer is A. So it's a good problem, because even I was second guessing myself, like, oh, divide by 0. So that makes sense before I even looked over here, and then I started looking at the choices, and then that's how I realized, oh, that could work. Okay. Oh, this is a huge graph. Okay. We're given this graph. I don't know why it's so big. The graph of the function f is shown in figure above, has horizontal tangents at x is 3 and x is 6, which we can see. If g of x is integral from 0 to 2x f of t dt, what is the value of g prime of 3? Oh, fundamental theorem calculus. Come on. This is easy. So g prime of x would be f of 2x times derivative with respect to x of 2x, which is 2 f of 2x. Okay, so g prime of 3 would be 2 times f of 6. What is f of 6? That is over here. It's close to -1, so it should be 18c -2. Yep, that's correct. This in the actual College Board graph, it actually is exactly -1. So answer C. Okay. A curve has slope 2x plus 3 at each point x, y on the curve, which the following is an equation of this curve if it passes through the point 1, 2. So slope is derivative, right? So dy dx is 2x plus 3. We want the curve itself, so we need to get y. We need to solve this differential equation. So we integrate both sides. So y is x squared plus 3x plus c. And they give us the initial condition, 1, 2. So 2 is 1 plus 3 plus c. So I plugged in x as 1, y is 2 into here. C is equal to 2 minus 4, which is minus 2. So y is x squared plus 3x minus 2. D. Function has Maclaurin series given by this guy, which the following is an expression for f of x. Okay, so just peeking at the choices, it's probably one of the Maclaurin series that we know. Okay, and they even give us the general term over here. So it might look kind of familiar. Okay, so then how I would approach this is, this looks kind of close to e to the x, because e to the x is x to the n over n factorial. So I probably want to kind of start with that. So let's say e to the x is x to the n over n factorial. Okay, and by the way, we can probably eliminate these three right away, because remember, sine and cosine, they alternate the sign within the Maclaurin series. It's alternating sine one. So this one doesn't alternate sine though, so we can probably eliminate these three quite safely. Okay, so we limit it down to two choices now. Okay, so then if I do this one, which is e to the x squared, I would have to replace x with x squared. So it would be x to the 2n, which is not quite what we have here. So I'm already thinking it's not e. Okay, but what happens if I do x squared e to the x? X squared e to the x would be summation n goes from 0 to infinity. X to the n plus 2 it would be over n factorial. Okay, doesn't quite look like this yet. So let me think. Maybe let's write it term by term actually. Okay, so from here, let's write it term by term, which would be, actually, let's write it from here also. It'll be 1 plus x squared over 2 factorial plus x cubed over 3 factorial, so on and so forth, right? So then x squared e to 2x's, I can just multiply each term by x squared. It'll be x squared plus x cubed plus x to the 4th over 2 factorial plus x to the 5th over 3 factorial, so on and so forth. Okay? And then this guy says minus x cubed minus x squared. So x squared e to the x minus x cubed minus x squared. Notice those are the first two terms. So it'll be x to the 4th over 2 factorial plus x to the 5th over 3 factorial, so on and so forth, which is exactly what we got there. So choice D. So once again, to recap how I got this one, this looks like e to the x. Very close to it. So that's how I first thought of maybe it's something e to the x. And I know that sine and cosine have alternating signed terms. It's like plus, minus, because cosine is like 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, so on and so forth. Sine is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, so on and so forth. So that doesn't alternate sign. It doesn't alternate sign here. So that's why I kind of safely eliminated A, B, and C. And I also eliminated E because e to x squared would be, term by term, it would be 1 plus x squared plus x to the 4th over 2 factorial plus x to the 6th over 3 factorial, and so on and so forth. So it doesn't quite match this either. Okay. So then by process of elimination, it's D, but then I showed the steps too to try to get it. Okay. Number of moose in a national park is modeled by function m that satisfies the logistic differential equation, this guy, where t is the time in years that m of 0 is 50. What is the limit as t approaches infinity of m of t? Okay, so this, you have to be able to pick out the carrying capacity of this logistic differential equation. Okay, usually it's like, so if our dependent variable, meaning our output is m, is like m on the outside, 1 minus m over something. And that something is usually the carrying capacity. So this is exactly in that form. So in that case, this is 200. Okay, as simple as that. What are all values of p for which this infinite series converges? Okay, so first of all, we can already use the fact that if p is equal to 1, the sequence would be n over n plus 1, and the limit as n goes to infinity of n over n plus 1 is equal to 1. Okay, so it's not equal to 0. So this would diverge by the test for divergence. So it cannot equal 1. So eliminate B and A right away because they include 1. Okay, now what about 2? Does it include 2? Okay, so it would be summation n goes from 1 to infinity, n over n squared plus 1. I believe this would diverge. So if we do the limit comparison test, we compare with the harmonic series. Okay, it will be limit as n goes to infinity of n over n squared plus 1 over n, which is limit as n goes to infinity of n squared over n squared plus 1, okay, which is equal to 1. That's the limit. This is greater than 0 and less than infinity. So since this guy diverges, this guy also diverges by the limit comparison test. So it cannot equal to 2 either. So we eliminate those two. Answer is E. Okay, That's how I would approach that. This worked out solution that I found did it a totally different way. So this is how I thought of it though. Okay, this one's clearly integration by parts. Hopefully you can tell that. I'm just going to do it the tabular method. U and dv, u would be x. We differentiate it until we get to 0. Sine 6x goes into the dv. We integrate it just as many times. So it'll be minus a 6 cosine of 6x, and then becomes minus 1 over 36 sine of 6x. Okay, we go diagonally and we alternate sign starting from plus. Okay, so we multiply all these together. It would be minus 1 over 6x cosine of 6x plus 1 over 36 sine of 6x plus c. And which one is that? That looks like B. Yes. Nice. Okay. Which of the following series diverge? Oh, this is everyone's favorite testing series. Okay, so the first one, does it converge or does it diverge? That's a geometric series. The common ratio, R, is sine 2 over pi. What is this value? You got to be smart about it. Sine of something is always between -1 and 1, okay? So when we absolute value it, okay? So let's assume that it's the worst case, that it's 1, okay? Because remember, I just said, sine can only be between -1 and 1. Okay, so let's assume it's the worst case, 1, or a -1. When we absolute value, it'll be 1. Okay, 1 over pi. Pi is 3.14. So this is for sure less than 1. So this would be convergence, actually. Okay, so this asks if it diverges, so we can eliminate any of the choices that say 1, because it converges, we just found. So we eliminate 3 of them already. Very nice. This one, we can rewrite as summation n goes from 1 to infinity, 1 over n to the 1/3 power. Okay, this is a p-series with p equals a third, which is less than 1. So this diverges. Okay, so it cannot be 3 only, so by process of elimination, it's D. But this one, how would we know if it converges or diverges? Well, we can take the limit of the sequence, I believe. Let's see. We get infinity over infinity, we use L'Hopital's rule. E to n over e to n, which is limit as n goes to infinity of 1, which is 1, which is not equal to 0. Test for divergence says this diverges. 2 and 3. Okay. Am I approaching the end soon? How many problems do I have? It should be. Okay, let's see if I can finish 4 problems quickly. Function f is continuous on closed interval 2 to 14 and has values as shown in the table above. Use subintervals these. What's the approximation of integral from 2 to 14? Found by using a right Riemann sum. Okay, so we're adding up rectangles. So the base of the rectangle, the first one, has a length of 5 minus 2, which is 3. Okay, so that's this subinterval, this subinterval, this subinterval, okay? And we want a right Riemann sum, so we're going to choose the right endpoints. So 3 f of 5, plus the next one has the base is 5, 10 minus 5, and then f of 10, we want the right endpoint. The next one is 14 minus 10, that's 4, and we want f of 14. Okay, so 3 times f of 5, that is what, 60 plus 18, I'll just write it out, plus 5 times f of 10, that is what? 150 plus 20. 4 times f of 14, that is 120. Okay, so this is this is 270, right? 270, 330, 350 plus 18, that is 368. I don't quite get that. I probably made some math error somewhere. 3 times f of 5, 60 plus, 24. So this is 374. Oh, that's a choice. Did I get it right? There we go. Okay, sorry for the simple math error there. This is clearly partial fraction decomposition. Hopefully you can tell. So let's do it. It would be a over x plus 2 plus b over x plus 1 is equal to 2 over x plus 2, x plus 1. Multiply both sides by this denominator. A times x plus 1 plus b times x plus 2 is equal to 2. Plug in easy numbers like x is negative 1. This would go away. Get b is 2. Plug in x is negative 2. We get, this will go away. Negative a is 2, so a is negative 2. So that our integral becomes minus 2 over x plus 2 plus 2 over x plus 1 dx. So this is just minus 2 ln of x plus 2 plus 2 ln of x plus 1 plus c. Okay, so do I get that over here? Oh, I copied it wrong. It was a 2x over here. Okay, so it'll be a 2x over here. So x is negative 1. We get b is negative 2. Okay, and when x is negative 2, then a is equal to, this will go away. So negative a is equal to negative 4. A is equal to 4. My bad. So this is a mistake page, or a page where I'm making a lot of mistakes. Sorry about that. So this is 4 over here, and this is a minus here. So this becomes a minus over here. So 4 ln of x plus 2 minus 2 ln of x plus 1 plus c. Is it d? Yes. Sorry about that again. Okay, but partial fraction decomposition. Okay, I'm running out of time. This is clearly fundamental theorem of calculus. Okay, so when we differentiate this, we get ln of, we plug in the upper bound as the variable of integration, so it'll be x cubed squared plus 1, and then we need to multiply by the derivative of the upper bound. Okay, so this is ln of x to the 6 plus 1 times 3x squared. E. That one's easy. Okay, 28. What is the coefficient of x squared in the Taylor series for this guy? About x is 0, or the Maclaurin series. So let's say f is, let's rewrite this as 1 plus x to the minus 2 power. F of x is equal to, okay, so that f prime of x is equal to, so we want the coefficient in front of the x squared. So we only need to differentiate up to the second derivative. Okay, so because if you remember Taylor series, is n goes from 0 to infinity. At the nth derivative at the center, in this case 0, x minus a, the center, to the n, so in this case a is 0, over n factorial. So in front of the x squared term, so that's when n is 2, meaning we take the second derivative only. So first derivative would be minus 2, 1 plus x to the minus 3. Okay, and the second derivative would be 6 times 1 plus x to the minus 4. Okay, we need to evaluate the second derivative at 0. So f double prime of 0 would be 6. Okay, so the coefficient out in front would be, or let's just write the whole term, 6x squared over 2 factorial, which is 3x squared. So it's d. Simple as that. Okay, that's it for the no calculate portion. Hopefully this was helpful for you if you got stuck on any problems. And please like and subscribe as always if I have helped you in any way. And please be on the lookout also for the calculator required portion if you're interested.